right, so today's topic is going to be arithmetic sequences. It's more specific than general number sequences. We did talk a little bit about it already, but today we're going to take the deep dive into arithmetic sequences. So an arithmetic sequence is when each term differs from the previous one by the same number. So let's write that out. Sorry about my sloppy handwriting. So each term differs from the previous term by the same number. Some examples. So for instance, if I have the sequence 2, 5, 8, 11, and 14, if I just take a quick look, to go from 2 to 5 is 3, and from 5 to 8 is 3. But the way that you show that something is an arithmetic sequence is you look for the common difference. And the way you do that is you take the second term and you subtract the first term. You take the third term, subtract the second term. You take the fourth term, subtract the third term, and all of these numbers must be the same. And in this case, we get 3 every time, so our common difference is equal to 3, and that is how we show that it's an arithmetic sequence. So then, another example, it could be 31, 27, 23, and 19. And if you look, all of these numbers go down, they don't go up. So they can differ and go down. It just has to be by the same amount, or they can go up. So in this case, since they go down, our common difference is going to be a negative number. So let's go ahead and find that so we can show that this is a arithmetic sequence, 27 minus 31. So our second term minus our first term is going to equal negative 4. 23 minus 27, also negative 4. And 19 minus 23 is also negative 4. So our common difference here is equal to negative 4, and we have an arithmetic sequence. All right, the general formula for an arithmetic sequence is our nth term is equal to our first term plus n minus 1 times the common difference. And we're going to use that to find general forms of a sequence, but we're also going to use it to find a common difference and a couple of other things. But notice how n here and here are the same color. This is my nth term. And here, this one is the same color as that one. U1 is my first term. And D is the common difference. And if I had something like U3, that would be my third term. So whatever number is down there, that's what term number I have. So we're going to show this sequence here, 2, 9, 16, 23, and 30. We're going to show that it's arithmetic first, and then we're going to find a formula for the general term. Then we're going to find the 100th term in that sequence, and then we're going to look and see if a couple numbers are part of that sequence. So show that it's arithmetic, then we take the second term, subtract the first one, take the third term, subtract the second, take the fourth term, and the last term minus the term before it is also 7. So yes, it's arithmetic, and D is equal to 7. So since we now know we have a arithmetic sequence with a difference of 7, we can go ahead and put that into our general formula. As soon as I get my pen back. So UN is equal to the first term. My first term is 2 plus, and then I've got N minus 1 times 7. And I really should clean that up and distribute this 7 to both of these, because I can simplify it, and I would get UN equals 2 plus 7N minus 7. And I can still further simplify that by combining those two numbers. So UN equals negative 5 plus 7N. That is my nth term formula. Now, if I want to find the 100th term of the sequence, U100 is going to equal negative 5 plus 7. And where there's an N, I'm going to plug in 100. So I get U100 is equal to negative 5 plus 700, which when I combine those two, I get 695. So that is the 100th term of the sequence. And if I want to know if 828 is a member of this sequence, I'm going to put, it could be, I don't know, but if it is, I'm just going to plug it into the nth term and try to find N. So I'd add 5 to both sides, and I'd get 833 equals 7N, and then I would divide both sides by 7, and I would get N equals 119. So yes, it's the 119th term of that sequence. And if I want to know if 2,341 is a member of the sequence, I'm going to do the same thing. I'm going to add 5 to both sides. I'm going to put 2,341 in for the nth term, add 5 to both sides, and I get 2,346 equals 7N. Then I would divide both sides by 7. And this time, though, when I solve for N, I get 335.143. So no, this can't be a member of the sequence because I can't have a decimal. N has to be a whole number in order for it to be a member of the sequence. So no, that's not going to be a member of the sequence. All right, so my second example we want to find K. They give us U1. U1 is 3K plus 1. They tell us that U2 is K, and U3 is equal to negative 3. So we have the first three terms. They also tell us that this is an arithmetic sequence. So that's going to be what allows us to solve this, because U3 minus U2 is going to be equal to U2 minus U1. This is our two common differences. They have to be the same. So we're going to go ahead and we're going to put u3, negative 3, minus u2, which is k. That has to equal k minus 3k plus 1. Here's the tricky part. I have to be careful and distribute that negative sign to both of those. So I end up with negative 3 minus k is equal to k minus 3k minus 1. And then I'm going to go ahead and I'm going to combine my like terms here. And I get negative 3 minus k equals negative 2k minus 1. I'm going to add 3 to both sides. And then I'm going to add 2k to both sides. And I end up with k equals 2. So k is equal to 2. And if I needed to, I could find the first 3 terms of my sequence now. u1 would be equal to 3 times 2 plus 1, which is equal to 7. u2 is just 2. And u3 is equal to negative 3. So, and if we look here, 2 minus 7 is negative 5, and negative 3 minus 2 is also negative 5. So there's our common difference. Final example is the trickiest. So we have 2 terms. We have u3 and we have u8. And we want to find the formula for the general term. We want to find un. We don't have a whole lot here to go on. There's our formula. We don't have the difference. We don't have the first term. But we're going to go ahead and use what we do have. We're going to do u8 instead of un. And instead of u1, we're going to use u3. We have u3. So where the n is, I have to put an 8. Where u1 is, I don't have u1. I have u3, so I have to put a 1. So this is what I'm going to end up doing. I'm going to end up using this. And I'm going to find D actually first. I do have u8. u8 is negative 17. u3 is 8. And then 8 minus 1 times D. So I have everything but D. I have 2 terms, and I'm going to use those to find D. So I'm going to go ahead and simplify this. I don't know why this keeps doing that, but it's annoying. So I've got negative 17 equals 8 plus 7D. If I go ahead and subtract 8 from both sides. Oh, that's not a 1. What am I doing? Up here, this is a 3. So I already screwed up. This is 5D, not 7D. This should be 3. Has to be the same number as that number. Okay, that's better. So now I'm going to subtract 8 from both sides. And I get negative 25 equals 5D. So when I divide both sides by 5, D is equal to negative 5. So now I have D. Now I could find the first term. this time I'm going to put in I'll just stay with U8 equals U1. Oh, and since I'm looking for 1, I'm going to put a 1 there this time, and I already know that the common difference is 5. And U8 is still negative 17. So let's go ahead and put in what we have. Negative 17 equals U1 times plus 8 minus 1 times negative 5. Let's put a parenthesis so we don't think that's subtraction. All right, so negative 17 equals U1. 8 minus 1 is 7 times negative 5. So negative 17 equals U1 minus 35. And if I add 35 to both sides, I get U1 equals 18. That's my first term. So now I have U1. I can just write the general term. 18 plus n minus 1 times negative 5. And now I can simplify. Seems like a lot of work. I know. It kind of is. So un equals 18 plus negative 5n plus 5. And I'm going to go ahead and simplify that even further. I can combine the 18 and the 5. And I get un equals 23 minus 5n. All right, that's enough for me. I'm sure it's enough for you. Good luck with your work, and thanks for listening.